bird. It's a plane. No, it's someone with curls. It's Math Girl. Okay, we're looking at 31B, 4 through 6. Aiden traveled 3 miles east and 11 miles north. Find the magnitude of the resultant. I'm always going to suggest that it's always good to draw a picture. Okay, so if you draw you like a map with north, south, west, and east, this is also, you have an XY axis. So Aiden traveled 3 miles east. Let me draw me some tick marks on here. 1, 2, 3. Okay, we're going to make this up higher. Okay, I'm not going to draw my 11 tick marks. So, she walked 3 miles to the east. I'm drawing that with an arrow because that's pointing to the east. So she walked 3 miles to the east and then she went 11 miles north. So we're just going to estimate and say that that's 11 miles north. So this is 3 miles and this is 11 miles. It says find the magnitude of the resultant. The magnitude means how long. How long is the resultant? If she went east and then to the north, the resultant always starts at the same starting place as the first vector. So the resultant is drawn from here to where she went. Walking to the east and to the north is the same as starting here and ending up in the same ending point. So the resultant starts at the same starting point and it ends at the ending point. So Aiden could have walked 3 miles east and 11 miles north, or she could have walked this path here, the resultant, and ended up in the same place. So what kind of triangle did we make when we drew this picture? A right triangle. For a right triangle, you can always use Pythagorean theorem, okay? I'm just going to label this as H because it's my hypotenuse. You can label it whatever you want. Books will label them all different. You might see it labeled as vector with an R. That means resultant vector. There's all different kinds of labelings you can label. For simplicity, I'm just going to label it the hypotenuse. That's my resultant vector. And how can we find the hypotenuse? We use Pythagorean theorem. So, using Pythagorean theorem, we can do 3 squared plus 11 squared equals hypotenuse squared. This is in miles. This is in miles. So our hypotenuse will end up in miles. So 3 squared is 9. 11 squared is 121. And that's h squared. That would be 130 equals h squared. And so to solve for h, take the square root of both sides. I am going to go ahead and put mine in decimal. I'm not going to leave it in radical form. You can simplify this and leave it as a radical, but I'm going to go ahead and put it into a decimal. So that came out to 11.4. So H equals 11.4 miles. So this hypotenuse, I'm going to go ahead and label it up here, is 11.4 miles. Okay. This theta will represent the direction. Okay. How far from 0 degrees? Remember, on the x-axis, that is 0 degrees. Okay. If we start at 0, then we rotate up. How many degrees is this resultant vector from 0? We're going to solve that in a minute. Number 5 says, using this same triangle, they want you to find the sine, cosine, and tangent of theta. Okay, so it's as if we were standing at theta. If you want to draw your little man, you're standing at theta. Okay, so sine theta is opposite over hypotenuse. So if I'm that little man, what's the side opposite of me? That would be the 11 miles. So that would be 11. Hypotenuse is always the same, 11.4. Then what they're wanting you to do is put that into a 4, they want you to go ahead and divide it out. 11 divided by 11.4 and put it to 4 decimal places. So 11 divided by 11.4 equals 0.9649. Okay, cosine theta. Cosine is adjacent over hypotenuse. If I'm standing here at theta, I'm that little man, what's the side adjacent to me? That would be the 3 miles. Hypotenuse, always the same. Hypotenuse is the side across from the right angle. So 11.4. This is your cosine value in fraction form. Then they want you to go ahead and divide that out into a decimal. 3 divided by 11.4. So 3 divided by 11.4, and they want you to put it to 4 decimal places, is 0.2632. Usually trigonometric or trig functions are to 4 decimal places. Now, tangent theta. Tangent equals opposite over adjacent. If I'm the little man standing there, what's the side opposite of me? 11. What's the side adjacent to me? 3. So in fraction form, tangent theta is 11/3, but let's put it into decimal. So 11 divided by 3, it would be 3.6667, because it was 666666. We're going to round to 3.67. Okay, that's what they're wanting you to do in number 5. Now, they're asking you to find theta, which is the direction of Adam's resultant vector. Okay, I'm going to redraw my picture down here. So here's a triangle that we had. We had this triangle, and that was 3 miles, 11 miles. I was going 3 miles to the east, 11 miles north. And so your resultant ended up being 11.4 miles. And we're trying to find theta. So if we need to find theta, we can use any one of those trig functions. So what we can do is, we said that sine of theta equals 0.9649, theta. Cosine theta equals 0.2632. And tangent theta equals 3.6667. You can use any one of these equations to actually solve for theta, because that's what we're trying to find. When you're wanting the direction means you are finding theta. So we already know the magnitude, the length of what this distance walked is 11.4 miles, but we need to know the direction. At what angle did he or she walk? So to find theta on your calculator, you have sine, cosine, and tangent buttons. But to find theta, you are doing it's called the arc sine, or the inverse of sine. If you do that for each one of these, theta should come to the same thing. So on paper, you see it as this. Sine, and you'll see to the -1 theta equals 0.9649. Same thing here. If you're taking the inverse of cosine, you'll see it with a -1 there. It's also called the arc, right here. It's also called the arc sine. That's the same thing as this. Or the arc cosine. That's the same thing as that. Or the arc tangent. That's just 2 different ways to write it. So this would be inverse of tangent. Each one of these should give us the same theta value. On your calculator, how you do that is you're going to use the second button on your calculator, because usually your calculator, your inverse will be up above the sine button. You have the sine button on your calculator. Can you get this? You have the sine button on your calculator, and right up above that, mine says A sine, which stands for arc sine, or yours will probably have the sine to the -1. So it's important you use your second function. So I'm not sure if you put in on your calculator You might need to do the second function of this first, then put in your decimal, and then hit enter. Each calculator is different. But in doing the inverse sign, you should come up with that theta on your calculator. It'll show 74.77. That is the value for theta. When you do the inverse of this number, the inverse sign of this number, you're actually solving for theta. So theta equals 74.77 degrees. If you do that for cosine, same thing. Use that decimal, the 0.2632, and then do the inverse of cosine using your second button. And you should get the same angle. Each one of these should give you the same angle. I got 74.77 degrees. Here, if I did this for tangent, I should get the same thing, 3.6667, and do the inverse of tangent, and I got 74.75. So it's because I rounded this number right here. So here I got 74.75 degrees, and it's because each one of these gets rounded. So you can see that theta, so that shows you it doesn't matter which one you use, you will get the same answer for theta. You can use any three of these trig functions to solve for theta. So our answer will be, I'm going to use the 74.77. So theta equals 74.77 degrees. What does that mean? That means that the direction that Aiden traveled was 74.77 degrees from 0. If I started here at 0, if I took this dry erase marker and then I rotated up 74.77 degrees, this angle is 74.77. She went at an angle of 74.77 degrees, and she went for 11.4 miles if she traveled along the hypotenuse. Alright, we're looking at 31D1. A plane flew 75 miles east and 125 miles north. What is the direction and magnitude of the resultant? Okay, I always recommend drawing a picture. So the first thing that it says is that a plane flew 75 miles east. So if you want to label, if you're dealing with east and north, so a plane flew 75 miles east. Okay, if this was like an XY graph, I'm just going to estimate 75 miles east, and then it turned and went 125 miles north. Well, if this represents 75, then I have to draw a longer line to represent 125. So this line up here needs to be longer to represent 125. It's like on a graph, if I went 75 over and then 125 up. Well, the 125 line should be longer than the 75 line. Okay? Then it says, what is the direction and magnitude of the resultant? The resultant starts from the beginning place. The resultant is, if I walked this distance and this distance, it would be the same as starting from the starting point and then ending at the ending point. It would be the same as walking this distance. This is supposed to be a straight line. That's not a very good straight line. So the resultant would be, if I walked this distance and this distance, the resultant is starting from the same starting point and ending at the same ending point. So I have drawn a right triangle, and this is the hypotenuse because it's across from the right angle. This was 75 miles and 125 miles. How do I find the hypotenuse? Pythagorean theorem. The hypotenuse is the length of that line, and that is the magnitude of your vector. So Pythagorean theorem, 75 squared plus 125 squared equals hypotenuse squared. 75 squared is 5,625 plus 125 squared, 15,625. Adding those two numbers together, 21,250. I need the hypotenuse, not just h squared. So take the square root of both sides. just going to take the square root of that and put it into a decimal. So the square root of that is 145.77 miles. Okay, that is the magnitude of my vector. Okay, that is the length. So I now know that that is, if I walked the distance starting at the same starting point and I walked the distance of the hypotenuse, I would walk a distance of 145.77 miles. Okay, now I want to know the direction that I'm walking. What angle is that? Okay, so if I'm that little man standing there, I showed in the last problem that you can use sine, cosine, or tangent theta to solve for theta. I'm used to always using tangent, so I will just use tangent. So, but you can use either three of those because you have all three sides. You have the side opposite of you have the side adjacent to you, and you have the hypotenuse. So you can use any of those. The reason I use tangent is because these two things were given to me in the problem. Tangent theta is opposite over adjacent. That would be the 125 is opposite of me. The side adjacent to me, if I was standing at theta, is 75. The reason I use these two numbers is because they were given in the problem. If I use sine and cosine, I have to use the hypotenuse, and I calculated that. What if I calculated the hypotenuse wrong? Now I'm using an incorrect number in my calculations, and it makes the next thing that you're calculating wrong. So since these were the numbers given to me in the problem, then that's why I use tangent. I try to use the numbers that were given to me because I know that those are correct. And since this was given to me and this was given to me, if I'm standing here, this is opposite, this is adjacent. The trig function that uses opposite and adjacent is tangent. So I use tangent theta because it's opposite over adjacent. So then I can turn this into a decimal. So I can say tangent theta, 125 divided by 75 is 1.6667, and you need to normally do it to 4 decimal places. Now, how do I find theta? You're taking the inverse of tangent. So you do the inverse function of 1.6667. So I'm not sure, you use your second button. So you use your second button and the tangent, and then you put this in, and then you should be able to hit enter. So when you do the inverse of tangent or the arc tangent, then that angle is 59, and the book might not even go to any decimal places. They might just say 59 degrees. I'm going to go ahead and leave it as 59.04 degrees, which means that this value up here, that is, this angle right there is 59.04 degrees. Meaning if I started here at 0 and I went up an arc at 59 degrees, I am walking if I walk this path, the hypotenuse path, I will be walking 145.77 miles at 59 degrees. Okay, the problems we did, the last two problems, we added two vectors together. We said, okay, someone walked east and then they walked north, and when you add those two vectors together, you get what's called a resultant vector. Well, not always. Well, our vector, when we add two vectors together, they won't be nice and neat, completely horizontal, then completely vertical. Okay, so in this case, we have two different vectors. We will add them together to get a resultant vector. So we're on 31D, number 2. It says the first vector is -4 on the x-axis and a +2 on the y-axis. Again, I recommend you draw a picture. So if I go -4, if I start at the origin, go over -4, that puts me here. And then if you go up, +2. That puts me at a point right there. Okay, that's at that point right there. So that is my vector. So that's my first vector. Then it says my second vector is -1 on the x-axis and +6 on the y-axis. Vectors have to be drawn head to tail. How do you draw your second vector? You draw a new axis at the head of your first vector. So I'm going to draw another X and Y axis, and the tip of that head is the origin of that new X and Y axis. Okay? So the tip of that head is on the origin. It's hard to tell. And so it says my second vector is -1. So going over in the -1 direction, then at +6. 1, 2, 3, 4, 5, 6. So if I go over -1 and then up +6, let's draw that with a second color. If I go over -1, up +6, that point would be right there. So that vector, you draw it from the origin, from where I went, and you draw an arrow like that. That is my second vector. So if my resultant vector always starts from the beginning where the person began, right there. And it will always end at the ending point. So my resultant vector would look like that. If I drew my line straight. It will start at the original origin and then end at that same ending point. This is my resultant. Okay, how do we determine the magnitude and direction of the final vector? With the resultant, what I can do is this, I knew that this was -4 over, that was -4 over, -4 over, and then a +2 up. Okay, and then my red vector was -1 over in the x direction. Okay, you can't see those numbers. Okay, it would be, I went -1 in the x direction, and then I went up +6. What you can do is you can add your x components and you add your y components. When you add vectors, you're adding your x components and your y components. So if we add our x components together, we're going to add our x components. We went -4 with that blue vector, and then we went over -1 with the red. So this final point should be over -5 if I drew a triangle. So -5. If I tried to draw a triangle with my black line, it's going to get pretty messy. But if I went over -4 with the blue vector, and then I went over -1 in the x direction, my total that I have gone in the x direction is -5. All I did was add my x components. I went -4 in the x direction for the blue one, and -1 in the x direction for the red one, and -4 and a -1 is -5. If I add my y components, I went up +2 for the blue vector, and then I went up +6 for the red vector. So adding those components, up +2, up +6, means I went up a +8. So if I redrew this, if I redrew my resultant, it would look like this. That basically, here's my triangle. I went over in the -5 direction, that's what that's telling me right there. And then went up a +8. And that's what this is telling me right there. So this is my resultant vector. It matches that black line right there. I'm right over here. So I went over a total of -5, adding my x components of the other two vectors, and then up a total of +8, adding my y components. Okay? We're going to call, well, let's do that in a minute. Okay, so how do I find the length of this resultant? I use Pythagorean theorem because I still have a right triangle. So Pythagorean theorem, using Pythagorean theorem can help me determine the length, the magnitude of my resultant. So using Pythagorean theorem, -5, use parentheses, squared, plus 8 squared equals hypotenuse squared. -5 squared is a +25. 8 squared is 64. and that would be 89. Then to solve for h, we take the square root of both sides. So the square root of 89 is 9.43. And that was, they didn't give us any units on here. So since they didn't give me any units, then I'm not going to have any units. So, but that's the magnitude of my vector. So this length, if someone started here at the origin and walked the path of the hypotenuse, they will walk 9.43, and we don't know if it's feet, inches, yards, miles. So they would walk 9.43. But now we need to find what direction that they are walking. We are going to call this angle right here alpha. Okay? We can solve for alpha. It's another Greek letter. Looks like a Christian fish. So we can solve for the Greek letter alpha. Again, I like to use tangent. Tangent alpha equals opposite over adjacent. If I'm standing at alpha, what is the side opposite of me? 8. What is the side adjacent to me? 5. I'm not going to use the negative as of right now. Well, okay, actually, let's just use the negative. So if I use negative 5, so turn that into a decimal. 8 divided by negative 5 is negative 1.6. So to solve for alpha, you are doing the inverse or the arc tangent of 1.6. So that's when you use your second button, and 1.6. And if you do that, then you end up with a negative 57.99 degrees. Here's the reality: when you're doing tangent, you don't need to use that negative. So we're just using, because we're not, the negative here just tells you the direction. It just tells me that I started at the origin, I went to the left. Okay, when I'm doing the tangent, I'm interested in the length of this, not the direction. So when you're using tangent, meaning opposite over adjacent, it's the length of the opposite over the length of the adjacent. This length is 5. The negative just tells me the direction that I went. So you don't really need to use the negative because you're concerned about the length. 8 divided by 5. So you can drop that negative because this negative doesn't tell you anything. So I'm just going to round that to 58 degrees. So we're going to say that alpha is 58 degrees, but we're not trying to solve for alpha. So this told me that this angle right here is 58 degrees. Anytime you're finding a direction, you always want the angle from 0 degrees. So the angle from 0 degrees means starts here and rotate to that vector. So I want to know what is this angle starting at 0 all the way rotating to this vector. So we're going to call this theta. This is really what we're wanting. This angle tells me the direction because that's starting from 0. 0 degrees is always here. Okay, so how do I find theta? What do I know about this angle and this angle? They are supplementary. They add to 180 degrees because they form a straight line. So to find theta, we can take this and subtract it from 180. So theta, equals 180 degrees minus 58 degrees. And that would be 122 degrees. So theta equals 122 degrees. Okay, so back in my picture, this angle is 122 degrees. It should be bigger than 90. It is an obtuse angle, so it should be bigger than 90 because here's 90 right there. If this was labeled, this is 90 degrees. This is 0. So we want the angle measuring from 0 degrees. So now we know when you add those two vectors, you will get a direction of 122 degrees and then a length or magnitude of 9.43.